Hello, grade 10. I hope you're all doing well. We left off last time we were together by finishing the different types of factoring, and the last lesson in this unit is taking a look at some of the places where we can use these skills. And the majority of where we have to factor comes up in grade 11 and 12, but this is just kind of a small preview of some of the places where it can be used. In the first example, we are given the area of a rectangle, and we know the area of a rectangle can be determined by multiplying the length and the width. So if we're looking for the length of the sides, then we're looking for what could we multiply together in order to get back to this polynomial expression. So we want to factor it. It is a trinomial, and remember we always check for a greatest common factor first. There is no greatest common factor in this one because our leading coefficient is 1. And then remember, if we have a trinomial, we're going to multiply the a value by the c value. So 1 times 15 is 15, and we're looking for two numbers that multiply to 15 and add to 8. And again, if you're not sure, you can make a list of your factors along the side. And then we are going to reverse FOIL this. So we're going to set up our binomials. We're going to say what times what gets us back to that first term of x squared. And then remember, we need to, these two numbers are the outside and the inside products. So we're going to say 1 times what gives us one of these numbers, and because it's a 1, it doesn't matter which one you choose, so I'll put in the 3, and then we're going to say 1 times what gives us the other number, and we can put in the 5. So one of them is the length, one of them is the width, and based on how our rectangle is drawn, this is going to be the longer side. Whatever x happens to be, we're adding 5 units to it, whereas here we're only adding 3. So I know in this example, the length is x plus 5, the width is x plus 3. The second example is one that comes up frequently in grade 11, because this particular function is what we call a degree 2 function, which when we graph it forms the shape of a parabola. And that's a large portion of what you learn in grade 11. And so even though we're going to get to it next year, I'm just going to kind of give you a preview here. If we go to graph this, then in the place of the y, we have an h, and in place of an x, we have a t. So this is actually the height of the ball, and this is the time that the ball is in the air. So I know that my ball starts up here, and how I know that you'll learn next year. And I also know that it's going to go up and then it's going to come down and hit the ground. So I'm going to take this function, and we want to figure out, first of all, just what would that be in factored form. Again, I'm going to check, first of all, is there a greatest common factor? And there is. So I'm going to pull out a -5, and the reason I'm pulling out a negative is because we don't usually want the leading coefficient in here to be negative. As you saw when you did the practice earlier in the week, last week I guess, it makes it more difficult. So I'm going to take out a negative so this becomes a positive. And then because I divided out a negative, when I go 25 divided by -5, that's going to give me a -5t. Or you could look at it and say -5 times what gets me positive 30, and it's going to be -6. And then remember, we're not finished. Once we remove the greatest common factor, we're going to check and say, okay, can we factor this inside further? It is a trinomial. I'm going to multiply a and c. So a happens to be 1, c happens to be -6. And we're going to say, are there two numbers that multiply to -6 and add to -5? And again, you can always list your factors if you need help determining those. In this case, those numbers are -6 and +1. So I'm going to then set up my factors. I'm going to leave that -5 out front. And we're going to create our binomials. T times t gets me back to t squared. And then again, this is a 1, but I'm going to say 1 times what gives me one of those numbers. Because it's a 1, we can choose either. So I'm just going to go -6. That takes care of the outside product. And then I'm going to say 1 times what gives me the other value, and it's going to be +1. And then you can always FOIL it out quickly in your head just to see when we multiply this back, t times t is t squared, -6t plus t is -5t, and 1 times negative 6 is negative 6. So we have this correctly factored. The second part of the question wants to know what is the height of the golf ball after 2.5 seconds. So the units give you a clue as to what we're looking at. So in this case, I can even go back and fill it in here because the question tells me t is time in seconds, h is height in meters. So if I actually write this in here, this is height in meters, this is time in seconds. So I want to know what is the height if, and I'm going to take my factored form, the time is 2.5. So instead of a t, I'm going to substitute in the 2.5 in both of those brackets, and then we're going to solve this. So what is the height? And then 2.5 plus 1 is 3.5. 2.5 minus 6 is negative 3.5. And then when we multiply these together, oh, I'll move this up here. When we multiply these together, we're going to have a negative times a negative will become a positive, and we end up with 61.25 meters is the height. So when we actually go to graph this, we can say, okay, when we're at 2.5 seconds, let's say here, we have a height that would be 61.25 meters. So there's kind of a preview, and we do a lot with quadratics in grade 11, of where some of these factoring skills are going to come into play. Today, our last example is similar to the rectangular one that we started with. This time we have a rectangular prism, and we're given an expression to represent the volume of the prism. And we're asked to factor that to determine the lengths of the sides. Now we know that the volume of a prism can be determined by multiplying the length times the width times the height. That's my clue that I'm going to need 3 factors. So the first thing we're going to do is check, is there a greatest common factor? 13 is a prime number, as is 5, so I'm not going to be able to divide a number other than 1 out of there, which isn't super helpful. But I can remove a variable. So I'm going to take out an x, and that's going to leave me with 6x squared minus 13x minus 5. And then we're going to keep going because I know already that I'm probably going to need 3 factors in the end. So I'm going to multiply my a value and my c value. 6 times negative 5 is negative 30. So I'm looking for 2 numbers that multiply to negative 30 and add to negative 13. So again, if you're not sure, you can always make a list of your factors, but those 2 numbers are going to be negative 15 and positive 2. So then I'm going to keep this x out front, and I'm going to say, okay, I know that the first terms have to multiply back to give me 6. Now I could put a 6 times a 1, but remember, 6 times something has to give me one of those numbers. I cannot multiply by 6 by any whole number to get one of these. So what are 2 other factors of 6 that could give us these? Well, we've got 3 and 2. 3 is a factor of 15, 2 is a factor of 2. So that is going to work. So I'm going to set up my 3x and my 2x. And then we're going to say 3 times what gives us one of these numbers? Well, we know 3 times negative 5 gives us that negative 15. And then I'm going to say 2 times what gives me 2. And we know that is a 1. So now we're fully factored, and we also have 3 factors representing our 3 sides that we would multiply together to get the volume. In the second part of the question, we're going to again determine the lengths of the sides as well as the volume of the prism if x is equal to 5 centimeters. So I'm going to take my 3 factors, and my first factor here is just x. So I know one of the side lengths is going to be 5 centimeters. My second side is 3x plus 1. So I'm going to take that 3x plus 1. I'm going to substitute 5 in for x. 3 times 5 is 15, plus 1 is 16. So I know a second side is 16 centimeters. So there's my first one. There's my second one. And then my third one, I'm going to take my last factor of 2x minus 5. I'm going to substitute in a 5. 2 times 5 is 10. 10 minus 5 is 5 centimeters. So those are my 3 side lengths. And then the last thing we're going to do is determine the volume. We know volume is length times width times height. And so we don't entirely know which side is which, but that's okay, it doesn't matter. We're going to multiply them together. So 5 times 16 times 5. 5 times 5 is 25. Times 16 gives us 400. And again, the units are important. So this is in centimeters, and we know volume, we're dealing with cubic units. So that gives us the volume of the rectangular prism. So